In this video, we're going to see where the trigonometry addition formulae come from. We're going to be using this diagram here, which has a couple of angles, alpha and beta here. We're going to work out a few things and then ultimately get formulae for sine of alpha plus beta and cos of alpha plus beta. Then we'll do tan and then the three formulae with alpha minus beta as well. So if we go, first thing to work out the following in terms of alpha and beta. First of all, we're going to work out angle EAF. Just remembered I meant to mention this. For simplicity, let's scale the diagram so that length AB equals 1. So there's A and there's B. So this length, let's just say that has a length of 1. We could choose any number we like because it's how the sides compare with each other that matters. So 1 is the simplest value to choose here. We can choose any number we like, we end up with the same results. So let's work out angle EAF. Let's identify it first. Where is it? There's E, there's A, and there's F. So EAF. So this angle up here. So we can use some geometry facts, some angle geometry here to work out the size of that angle EAF. Right, please understand that this angle here is alpha and this angle here is beta. So let's look at a geometry fact we can use, an angle geometry. In fact, first of all, it would be worth pausing the video and having a go yourself because it's using GCSE angle skills to work out the size of this angle up here. You're going to get it in terms of alpha or beta. So please pause the video, have a go at that. Right, hopefully you've had a go at, let's see if you got the same as me. So I'm going to use the fact that we have parallel sides here. I know the diagram doesn't point out that these are parallel, but they are. So DB along the bottom is a horizontal line. EF is also horizontal. So if you hadn't realized that, you could always pause the video again and have another go. But EF, DB are parallel, so we've got alternate angles here, which means this angle is alpha. They're sometimes called Z angles, but the proper name is alternate angles. So that is alpha. Next up, the other side of that angle here. Well, together, alpha and this one I've just labeled green, together they make a right angle because the other side of this straight line is a right angle, 90 degrees. So together they make a right angle, which makes this green one 90 minus alpha. And therefore, because angles in a triangle add up to 180 degrees, and since triangle AEF is right angled, that means the angle we're looking for and the one I've labelled in green, together they make 90 degrees. So therefore, this angle here must be alpha. So we can tick off first step, we worked out angle EAF. Next, work out side BE using triangle ABE. Let's identify triangle ABE. So there's triangle ABE. It's right angled because we have a right angle here. So using that triangle, work out side BE. So this is BE here. There's E, there's B. Work out that side. You're just going to be using GCSE trigonometry. It's a right angle triangle trigonometry. Please work out, and it's going to be in terms of alpha and or maybe beta. Work out side AB. Pause the video. Sorry, side BE, not AB. BE. Pause the video and work that out. So triangle ABE is right angled. One of the angles is beta. The other one, we haven't got a nice label for it. So I'm going to use beta as my angle. Remember, we chose to let the side AB equal 1. We could have chosen any number because it's the sides in comparison with each other that matters. So we'll go nice easy number, we'll go number 1. So I'm going to use beta. This is the hypotenuse because it's opposite the right angle. And I want to work out the adjacent. So hypotenuse, adjacent, that means we're going to use cos. So cos of the angle is the adjacent, which is BE, of the hypotenuse, which is 1. So therefore, side BE is equal to cos beta. Next up, step 3, again using triangle ABE, this time work out side AE. So same triangle, this time we're working out AE. Once again, right-angled triangle trigonometry, pause the video and please work out AE. So again, I'm going to use angle beta, the hypotenuse, which is 1, but this time the opposite is what I want to work out. So it's sine, because it's opposite in the hypotenuse. Sine of the angle is the opposite, divided by the hypotenuse. So therefore, side AE is sine beta. Next, we're going to use a different triangle, triangle BDE. So that's this one down here, BDE. Again, it's right angled, and work out side ED. Well, hopefully you get the hang of this now. Pause the video, use right angled trigonometry, and work out side ED. So here's the triangle we're going to use. I've shaded it in so we can see it a bit more clearly. Triangle BDE, work out side ED. We've got our right angle here. We've got this angle alpha. We might as well use that one rather than using the other one. So alpha, we're trying to work out the opposite. I don't know the adjacent, but I do know the hypotenuse. The hypotenuse is EB or BE. Doesn't matter which way around you put the letters. We've already got that. So it's opposite in hypotenuse, so we're going to use sine. So if you hadn't noticed that, pause the video and now work out length ED using sine of the angle. So sine of the angle is the opposite, which is ED, or DE, the order of the letters doesn't matter, over the hypotenuse, which is BE. BE or EB, same thing. So it's side ED that we want, so rearranging this to get ED on its own, it's going to be BE multiplied by sine alpha. We've already worked out BE. BE was cos beta. So it's cos beta, which was BE multiplied by sine alpha. There you go, one more step, step 5, and then we can use these to work out a formula for sine of alpha plus beta. So step number 5, use triangle AFE and work out side AF. So triangle AFE, this small one up here, once again is right angled. We've got an angle of alpha and an angle of 90 minus alpha. It's simpler to use the angle alpha in our working out. To work out side AF. Pause the video and do that. Right, well, it's AF that we're trying to work out, which is the adjacent to the angle I'm going to be working with. I don't know the opposite. We have not worked out EF, but we have worked out the hypotenuse AE. The hypotenuse opposite the right angle. We've got AE already from step 3. So it's hypotenuse and adjacent. That means it's cosine. So cosine of the angle I'm working with is the side that's adjacent to that angle over the hypotenuse. Now it's AF that we want. So I've got to rearrange this. AF is going to equal AE times cos alpha. AE times cos alpha, and AE we know from step 3 with sine beta. So it's sine beta cos alpha. Now we're in a situation where we can work out a formula for sine of alpha plus beta, and we're going to use triangle ABC to do that. Here's A, here's C, here's B. So it's ABC. I'm just going to shade that in. There it is, triangle ABC. BC. It's another right angled triangle. And the way the diagram was set up in the first place means this angle down here is alpha plus beta. All of that angle is alpha plus beta. So use that triangle, get a formula for sine of alpha plus beta. Sine is what we want, so we're now going to be working with the opposite and the hypotenuse. So sine of alpha plus beta, sine of this angle is the opposite of the hypotenuse. The opposite to that angle is this side here, AC, and the hypotenuse is 1, so it's just going to be AC over 1. Now you might be thinking, but we haven't worked out AC. So a bit of problem solving needed here. Look at what we have worked out and think, how can we figure out the length AC from what we have worked out? Pause the video and resume when you have worked out how we can get the length AC. Right, well, hopefully you noticed that we do have the length ED. We found that was cos beta sine alpha. And we've worked out the length AF as well. The length AF, that was sine beta cos alpha. And together, the lengths ED and AF, they make the length AC. So this is a rectangle here, so all these lines are vertical. So the length AC is the same as ED plus AF. Therefore, sine of alpha plus beta, which we worked out earlier was AC divided by 1, so it's just AC. So AC is the length AF plus the length ED. In other words, it's sine beta cos alpha plus cos beta sine alpha. Now the order I've written these terms in doesn't quite match the order in the formula book, but we know that when you multiply two numbers together, the order doesn't matter. So for example, sine beta multiplied by cos alpha, it's the same as when you do cos alpha multiplied by sine beta, and over here as well. This is the same as sine alpha multiplied by cos beta, and also when you add numbers together, it doesn't matter which way around you do it. So this term could have been written first, or that term could have been written last, and so on. If you're doing A-level maths, you should be very comfortable with all those facts anyway. On we go. Now work out the following. Side BD, using triangle BDE, and side EF, using triangle AFE. So pause the video and try and work out those two things. Right then, side BD, triangle BDE, I've shaded that in. So BD is the side that is adjacent to the angle alpha. And then we do know the opposite, and we also know the hypotenuse as well. So you can either get this in terms of cos alpha, using the adjacent and the hypotenuse, or sine alpha, but then actually no, you wouldn't do sine alpha because then you're using the opposite and the hypotenuse. We want to make sure we definitely use the adjacent. So yeah, definitely want to use the adjacent. So we could do tan because we know the opposite and the adjacent. I'm just going to go with cos, using adjacent and the hypotenuse here. So using adjacent and hypotenuse, cos alpha is the adjacent, which is BD, over the hypotenuse, which is BE. We worked out BE in step 2. So therefore BD, which is what I'm trying to work out, is going to equal BE multiplied by cos alpha. BE was cos beta, so it's cos beta times cos alpha. Yes, again, the order of writing these doesn't matter. You could have written cos alpha multiplied by cos beta. It's the same thing. Now on to triangle AFE and work out side EF. I'm using triangle AFE, this small one up here, to get side EF. So EF is opposite the angle alpha, so I'm going to use sine of alpha is the opposite, which is EF, over the hypotenuse, which is AE. We worked out AE in step 3, so by rearranging this, we get EF is AE multiplied by sine alpha, in other words, sine beta multiplied by sine alpha, which I could have written the other way around, as sine alpha multiplied by sine beta. Now we can use triangle ABC, get a formula for cos of alpha plus beta. So pause the video and have a go at that. So we're back with this big triangle ABC. We want a formula for cos of alpha plus beta. Remember, all this angle here is alpha plus beta. If it's cos we want, then we've got to be using the adjacent and the hypotenuse. So cos of alpha plus beta is the adjacent, which is BC, over the hypotenuse, which is 1. So that means it's just BC. So now have a look at the diagram. Do we know BC? If not, then how can we work it out? Pause the video and work out a length for BC. Right then, so BC isn't something we've worked out, but we have worked out BD, and we've worked out EF as well. And we can use both of those results to get the length BC. So BD is cos beta cos alpha, and then we want to take off EF, so take off sine beta sine alpha, and that leaves us with the length BC. That leaves us with BC. So therefore, BC, which we now know is equal to cos of alpha plus beta, is cos beta cos alpha, take away sine beta sine alpha. I'll just mention this one final time. I could have written cos alpha multiplied by cos beta, the other way around, and I could have written sine beta multiplied by sine alpha, again the other way around. Okay, now we're going to use a couple of very important results and identities to get sine of alpha minus beta, cos of alpha minus beta, and then we'll do the tan results as well. First up at the top of the screen, sine of negative x. Well, that is always the same as negative sine x. If you draw the graphs of sine of negative x and negative sine x, you'll see they are identical. So this is an identity that is true for all values of x. That's why it's an identity. That is worth knowing from memory. Sine of negative x is always the same as negative sine x. It often comes in useful, not just for this proof, but it comes in very useful in other topics. We also have cos of negative x. So if you drew the graph of cos of negative x, it would be a reflection in the y-axis of the cos x graph. And since the cos x graph has symmetry in the y-axis, you get exactly the same thing. So it turns out that cos of negative x is always the same as cos of x. Again, it's an identity true for all values of x. We're going to use these two results, which I'll say again are worth memorizing, not just for this topic, but for lots of topics. We're going to use them to get a formula for sine of alpha minus beta. So we're going to use what we worked out. We worked out sine of alpha plus beta. We worked out it was sine alpha cos beta plus cos alpha sine beta. That might be in a slightly different order to how I wrote it earlier. Anyway, we're going to replace beta with negative beta, and that will give us a formula for sine of alpha take away beta. So using that and replacing beta with negative beta, that's all I'm doing, just replacing it. And now use the two results at the top of the screen. So cos of negative beta is the same as just cos beta. But sine of negative beta is negative sine beta. I need the brackets around that because it's cos alpha multiplied by minus sine beta. Very important brackets here. Without the brackets, it would mean cos alpha take away sine beta, so you must put the brackets in. But when we simplify this, well, I'll write it over here. We have the result that we're given in the formula book: sine alpha cos beta, and then take away cos alpha sine beta. And that's how to get sine of alpha minus beta. We're going to do a very similar thing to get cos of alpha minus beta now. Very similar. So here's what we found earlier. Cos of alpha plus beta is cos alpha cos beta, take away sine alpha sine beta. Again, I might have written this in a slightly different order to how I did before, but it doesn't matter. So now if we replace replace beta with negative beta, and then use the two results at the top of the screen. Cos of negative beta is just cos beta, and sine of negative beta is negative sine beta. That is being multiplied by whatever's next to it, so it needs to go in brackets. Now when you expand these brackets and tidy up, we get the result that we know: cos alpha cos beta, and then plus sine alpha sine beta. Just two identities left. We're going to prove tan alpha plus beta now, using the results for cos of alpha plus beta and sine of alpha plus beta. So tan of alpha plus beta is what we want, using an identity that we have from AS Maths. Sine of alpha plus beta over cos of the same angle will be the same as tan of that same angle. So now let's write out the two results that we got earlier for sine of alpha plus beta and cos of alpha plus beta. There we go. Now remember what this identity looks like for tan of alpha plus beta. We get everything in terms of tan. So pause the video and have a think. What can we do to this fraction to make it look like that? If you need a clue, then look at the first term in the denominator. Look at what it is at the moment. Look at what we would like it to become. Pause the video and have a think. What should we do? Right, well, I hope you came to the conclusion that we're going to need to divide both the numerator and the denominator by cos alpha cos beta. If we don't do both the numerator and the denominator, then we will change the value of the fraction, and we don't want to do that because then it won't equal tan of alpha plus beta anymore. So here's what we need to do: divide both the numerator and the denominator by cos alpha cos beta. If you struggle to do that in one step, then break it up into two steps. Divide by cos alpha first, and then divide by cos beta. In fact, I'm going to do it that way. I'm going to divide by cos alpha first, and then I'm going to divide by cos beta. So every single term, and there are 4 terms, 2 in the numerator and 2 in the denominator. So first term in the numerator, divide that by cos alpha, and I get tan alpha cos beta. Second term divided by cos alpha leaves me with just sine beta. First term in the denominator divided by cos alpha, I'm left with just cos beta. And the second term divided by cos alpha, I get tan alpha sine beta. Now we're going to divide every single term by cos beta. So the first term in the numerator, tan alpha. Second term, tan beta. In the denominator, first term 1, and then take away tan alpha tan beta, which is the result we were hoping to get. So that's how we get tan of alpha plus beta. To finish off this video, we're now going to get tan of alpha take away beta. So let's recap the results from earlier. If sine of negative x is always negative sine x, and that's true, it always is, and cos of negative x is always the same as cos x, then what would tan of negative x always be the same as? We'll pause the video and work it out. It shouldn't take too long. So it's going to be sine of negative x over cos of negative x, which is minus sine x on top, cos x underneath, which means it's always negative tan x. So tan of negative x is always negative tan x. Choose any value of x and tan of negative x will be the same as negative tan x. So now we can go back to our identity for tan of alpha plus beta and replace all the betas with a negative beta. So replace beta with negative beta. And then use this result. Tan of negative beta will be the same as negative tan beta. And then tidy this up. Just the denominator needs tidying up. And we end up with the result that you were hopefully expecting. Tan alpha take away tan beta in the numerator, and 1 plus tan alpha tan beta in the denominator. And that shows where the 6 trigonometry addition formulae come from.